Hello everyone, you're welcome to Learn Maths with me. In this channel, I'll be taking you through in-depth tutorials covering a wide range of topics from basic arithmetic to advanced maths. Today we'll be taking a look at the third part of the topic probability. And before we continue, I would like us to look at the solution to the question from the last video. And it reads, if I pick a card from a well-shuffled pack, what is the probability that the card I picked is a red or an ace? Now, a pack of cards has 52 cards. It has 26 red cards and 26 black cards. So the probability of picking a red card will be 26 over 52. Also in the same pack of cards, we have 4 aces. The probability of picking an ace therefore will be 4 over 52. And then we also have the possibility of a red card that is also an ace card. We have 2 red cards that are aces and 2 black cards that are also aces. So the probability of picking a red card or an ace card will be 26 over 52 plus 4 over 52 minus 2 over 52. So we have 28 over 52, which is equals to 7 over 13. Let's quickly do a recap. The OR rule, which we did in the last video, it says that the probability of an event A or an event B occurring is the probability of an event A plus the probability of an event B minus the probability of A and B occurring together. Now, we also said for mutually exclusive events, there are events that do not happen together. So the probability of A and B occurring is 0. So that means that the probability of an event A or event B occurring is equals to the probability of an event A plus the probability of an event B. Today we want to look at the multiplication rule for independent events. Now, when we say independent events, that means that if you have an event A and an event B, event A does not depend on event B and event B does not depend on event A. So if we want to get the probability of an event A and the probability of an event B occurring, it is the probability of an event A multiplied by the probability of an event B. That is if the two events are independent. Now this is and. That's the probability of one event and another event occurring. The previous one that was an addition was the OR rule. That's the probability of an event A or an event B occurring. But in this case, it is the probability of an event A and an event B occurring. Let's take a look at an example. It says that 2 coins are flipped. What is the probability that the both land heads up? Now, if I flip the first coin, the outcome that I get does not affect the second, flipping the second coin. If I flip the first coin and I get a head, it doesn't affect it when I flip the second coin. So these two events are independent. So the probability of getting a head in event A is 1 over 2. And the probability of still getting a head when I flip the second coin, which is event B, is also 1 over 2. So the probability of getting A and B is 1 over 2 times 1 over 2, which is 1 over 4. Now let's look at conditional probability. This is when the probability of an event is dependent on the outcome of a previous event. So if I have 2 events, for example, and I carry out my first event, if my second event is dependent on the results that I get from the first event, then it is a conditional probability. An example here is, in this jar I have 15 counters. If I pick 2 counters out of the jar, what is the probability of picking 2 red counters? Now I want to look at the probability of picking 2 red counters. By the time I carry out the first event, which is picking out the first red counter, the jar is not going to have 15 counters anymore. I'm going to be left with 14 counters. And then because I'm calculating the probability of picking a red counter, out of the 4 red counters in the jar, I'm going to be left with 3 red counters. So my second event, which is the probability of picking the second red counter, is dependent on the first event. So let's look at the solution. The probability of picking the first red counter will be 4 over 15, which is the number of red counters that I have divided by the total number of counters that I have in the jar. Now the probability of picking the second red counter, like I explained, After picking the first red counter, I'm left with just three counters. And after picking the first counter from the jar, I'm left with just 14 counters remaining. So the probability of picking the second red counter will be 3 over 14. So now the probability of picking two red counters will be 4 over 15 multiplied by 3 over 14, which is 12 over 210. And if we simplify this, it will give us 2 over 35. Let's take a look at another example. Two cards are drawn from a standard pack of cards without replacement. What is the probability that both cards are red? Now, note the word without replacement. So that also tells us straight away that this is a conditional probability, because after I've drawn my first card, I didn't replace it, then I go ahead and draw my second card. So the probability of getting the first card, of drawing the first card, which is probability of the first event, is 26 over 52, because I have 26 red cards in the pack of 52 cards. So the probability of getting a red card will be 26 over 52. Now, because I have taken out a red card from the pack, I no longer have 26 red cards. I now have 25 red cards remaining. And then I no longer have 52 cards in the pack. I now have 51 cards remaining. So the probability of drawing my second red card will be 25 over 51, because the second event is dependent on the first event. Now, what is the probability of drawing two red cards? I've gotten the probability of drawing the first red card, and I've also gotten the probability of drawing the second red card. So the probability of drawing two red cards will be 26 over 52 times 25 over 51. Cool. A bag of sweet contains 5 toffees, 3 chocolates, and 2 mints. Emmy and Sophie each pick one sweet at random. What is the probability that they pick sweets of the same kind? So the probability that they pick sweets of the same kind is the probability that they pick 2 toffees, or the probability that they pick 2 chocolates, or the probability that they pick 2 mints. Now let's go ahead and do the calculation. We have 5 toffees, we have 3 chocolates, and we have 2 mints. Altogether, we have a total of 10 sweets in the bag. So the probability that I pick my first toffee will be 5 over 10, which is the total number of toffees, the number of toffees divided by the total number of sweets, 5 over 10. The probability that I pick the second toffee will be 4 over 9, because remember, my 5 toffees, I've picked one out of it, so I have 4 left, and then I don't have 10 sweets anymore, I have just 9 left. So the probability of picking the second toffee is 4 over 9. So that means that the probability of picking 2 toffees will be 5 over 10 multiplied by 4 over 9, which will give me 20 over 90. Now, what is the probability of picking 2 chocolates? The probability of picking the first chocolate, because I have 3 chocolates out of 10, the probability of picking the first chocolate will be 3 over 10, while the probability of picking the second chocolate will be 2 over 9. So the probability of picking 2 chocolates will be 3 over 10 times 2 over 9, which is 6 over 90. Now, let's go ahead and look for the probability of picking 2 mints. The probability of picking my first mint will be 2 over 10, because I have 2 mint sweets and I have a total of 10 sweets in the bag. Now, after I've picked my mint, the first mint, I have just 1 mint left and I have just 9 sweets left. So the probability of picking the second mint will be 1 over 9. So the probability of picking 2 mints will be 2 over 90. Now, the question is asking, what is the probability that they pick sweets of the same kind? So the probability that they pick sweets of the same kind can be either of these options. It can be the probability of picking 2 toffee sweets, or the probability of picking 2 chocolate sweets, or the probability of picking 2 mint sweets. So I'm going to go ahead to add all these answers to know the probability of picking 2 sweets of the same kind. So that will be 20 over 90 plus 6 over 90 plus 2 over 90. So the probability of picking 2 sweets of the same kind will be 28 over 90. If you have any questions, please feel free to drop it for me in the comment section. Thank you for watching.